Hello and welcome to the new style Edexcel GCSEs. These are the ones that go from grades 9 through to 1. This is paper 1 MA1/3F. It's the third paper in the foundation tier. It is a calculator paper and we're picking up in question 21. In a survey, the outside temperature and the number of units of electricity used for heating were recorded for 10 homes. The scatter diagram shows this information. Okay, so we have the number of units up the y-axis and the outside temperature along the x-axis. Molly says, on average, the number of units of electricity used for heating decreases by 4 units for each degree C increase in outside temperature. Part A says, is Molly right? Show how you get your answer. Okay, so the first thing we can check is the relationship. Is the number of units of electricity decreasing with an increase in outside temperature? And the answer is yes. The x's do seem to be getting lower and lower on the y-axis the higher up they go along the x-axis. So she's right that it's decreasing, but is it decreasing by 4 units for each degree C? For that we're going to have to estimate the slope. And here we've got just a load of x's, so we're going to need to draw a line of best fit and then measure the slope of the line of best fit in order to estimate the slope of this data. So we just judge by our eyes, we take our ruler and we try to draw a line that sort of covers as many x's as possible, that's as close as possible to as many x's as possible, and that's probably as best I can do. Alright, so we're now looking for a couple of points on this line that can define this line. So one point that's very easy to read is 10 across the x-axis and 60 up the y-axis. Those big thick lines make it really easy to see. So one point is 10, 60. And we can also define the line by, well, we can go either to the 20 or the 15. I'm going to go to the 15 because I think that line's very close to the 50. I don't think it's exactly on the 50. I think it's just one square below the 50. Now, between 40 and 50 there are 5 little squares, so each little square is worth 2 units of electricity. So one little square down from the 50 is 48. So our other point is 15, 48. So we want to divide how far it's changed on the y-axis by how far it's changed on the x-axis to get the actual slope, because we're looking to see how much the number of units of electricity have changed for each degree C increase in temperature. So how far up the y-axis has it changed? Well, let's start with this point here. So it's gone from 60 down to 48. And if it started at 60 and it moved to 48 on the y-axis, it started at 10 and it's moved to 15 on the x-axis. So the y-axis has gone down and the x-axis has gone up. So we're going to expect this to come out to be a negative slope. So 60 minus 48, well, you add 2 to 48 to get 50, 10 to 50 to get 60. So that's equal to 12 divided by, and if you've got 10 and you're taking away 15, you're going to end up with negative 5. So this is indeed a negative slope, and it's negative 5 over negative 12 over 5. So we could use a calculator for that, but 2 times 5 is 10, remainder 2, so that's 2 and 2/5, which is 2.4. So the slope is equal to negative 2.4. Again, you are allowed to use a calculator though. So Molly is wrong, and I'll just put slope equals negative 2.4 as my reason why. I'll put not 4 or not negative 4. Okay, so that's part A. Part B says you should not use a line of best fit to predict the number of units of electricity used for heating when the outside temperature is 30 degrees C. Give one reason why. Okay, well if we carry on using this line of best fit and we extend that line down to 30, we'll see that people are using a lot less electricity when the outside temperature is at 30. But let's be honest, who uses electricity to heat their home when the outside temperature is uncomfortably warm? If anything, they will use electricity to put fans on or air conditioning, so the electricity might start to go up as the temperature starts to get over 25. So we can't extend the line of best fit beyond the available data because that involves making too many assumptions about the data. So I'm actually going to type this, and I'm going to put can't extend line of best fit beyond available data without making assumptions about the data. Who uses electricity to heat their home when outside temperature is uncomfortably warm? Okay, I hope that was helpful, and I'll see you in the next video.